Alright guys, today we got one little piece from 3.7 and then we're going to primarily focus on 3.8. The one thing from 3.7 that we're talking about today is the determinant. The determinant is the difference of the products of the diagonals. Okay, so let's say I have this matrix ABCD. Alright, if I want to calculate the determinant, we multiply top left times bottom right, A times D, and then B times C, and we subtract, and that'll give us a number. And we'll use that number later when we do inverses. So an example here, if we wanted to do the determinant of 5, negative 4, 8, 9, we cross multiply here, 5 times 9 minus 8 times negative 4. So we'll get 45 minus a negative 32, 77. Okay, just one little thing there from section 3.7. There's going to be 3 problems on that in your homework today. Shouldn't be too bad. Alright. Then we move on to 3.8, and we're solving equations with matrices. Okay, so there's just a couple things to get to up front in order to be able to do the solving. Alright, so we got to first talk about the identity matrix and the inverse matrix. The identity matrix is 1, 0, 0, 1 for a 2 by 2, or 1, 0, 0, 0, 1, 0, 0, 0, 1 for a 3 by 3. Okay, the identity matrix, when it's multiplied by another matrix, that second matrix will stay the same. Kind of how 0 is the addition identity, right? 0 plus 7 equals 7, it stays the same. And 1 is the multiplication identity. So like 10 times 1 stays at 10, it stays the same. So that would be what these matrices do. When you multiply these times another one, they stay the same. Okay? So we're not really going to be multiplying by that, because the answer would just be the other matrix. But we will use that to tell if we have inverses. Inverse matrix, okay, we have 2 matrices are inverses if their product is the identity. So if I multiply 2 inverses together, they should come out to be 1, 0, 0, 1. Kind of like when we do 2/3 times 3 halves, they're inverses here of each other. So when I multiply them, they equal 1, which is the multiplication identity. Same idea here. Okay? So here we go. You're going to be given problems like this on your homework where there's going to be 2 matrices, and you'll have to determine if they're inverses of each other. And the way to do that is just to multiply them. So we'll have 3 times 1 and negative 2 times 1. That's 3, and a negative 2 is going to be positive 1. Okay? 3 times 2 is 6. Negative 2 times 3 is negative 6. Those will go together for a 0. Negative 1 times 1 is negative 1. 1 times 1 is positive 1. Those add together for a 0. And then we have a negative 2 and a positive 3 for a 1. So 1, 0, 0, 1, that's the identity matrix. These 2 are inverses of each other. So you'll have problems like that. If it comes out as something different besides 1, 0, 0, 1, not inverses. And just because you get 1, 0, 0, don't automatically go and fill that last one in. The book could be tricky there and give you a trick question and have it change on the very last one. Alright, so we know how to test 2 matrices to see if they're identities, or to see if they're inverses. What if they give you 1 matrix and they want you to calculate the inverse? This takes a little more time. There's another pattern here to it. So for any matrix, any 2 by 2 matrix A, B, C, D, we find the inverse by doing 1 over the determinant. That was that very first thing we talked about. 1 over that determinant times D, negative B, negative C, A. This got all switched up, but there's a pattern to it. The first diagonal from the determinant just trades places. The second diagonal, they have opposite signs. Okay, so it's really not that much different. And remember what the determinant was. Diagonal minus the diagonal. AD minus CB. So to find the inverse matrix, we would do 1 over A times D minus C times B, or B times C, and then times that number like a scalar multiplier through the whole matrix like this. D, negative B, negative C, A. Okay, let's practice. We have negative 1, 0, 8, negative 2. Okay, so first we need the determinant. 1 over A times D. Negative 1 times negative 2 is positive 2, minus 0 times 8 is 0. Now we need to move these around. Negative 1 and negative 2 trade spots, so negative 2 is up here, negative 1 is down there. Okay, negative 0 is still 0, and this goes to negative 8. Simplify our front number here, 1 over 2 minus 0, that's just going to be 1/2. And now I multiply that through to everything. Negative 1, 0, negative 4, negative 1/2. This is the inverse matrix to our original one up here. If I were to multiply these two together, I'd get 1, 0, 0, 1. Okay, so you're going to have a few problems like that. It seems confusing at first. Once you start doing a few and get the pattern down, it's really easy. Alright, now the last one. Solving systems with matrices. We finally get to use that $100 calculator to do some fancy math work here. Alright. So remember doing these systems of equations, we'd have to do it with substitution, elimination, graphing. This one looks like it'd be perfect for elimination. Right? Just multiply that whole top row by 3 and you're ready to go.